Now we will discuss about the equation of stationary wave. Equation means a mathematical expression of a stationary wave, like a mathematical expression for the simple harmonic motion, such like that it is also similar. So let us take a stationary wave of displacements which are possessed in opposite direction, like this. So one is moving from left to right, another one is moving from right to left, relative motion. So from left to right, let us suppose the displacement is y1. So the equation is a sin kx minus omega t. So from right to left, let us say the displacement y2 is a sin kx plus omega t. The net displacement capital Y is equal to y1 plus y2. Therefore, capital Y is equal to y1 is a sin kx minus omega t plus y2 is a sin kx plus omega t. So here it is sin a minus b, here it is sin a plus b. I am taking common a. So this is sin kx minus omega t plus sin kx plus omega t. In trigonometry, a formula is there. That formula sin a minus b plus sin a plus b is equal to, we know that the relation sin a plus sin b is equal to 2 cos a minus b by 2 into sin a plus b by 2. So therefore, here it is sin kx minus omega t plus sin kx plus omega t. In place of a, it is kx minus omega t. In place of b, it is kx plus omega t. So the expression y is equal to 2a cos kx sin omega t. This is the net displacement. If you compare this net displacement with SHM equation, it is equal to y is equal to a cos omega t. So this comparison will give a is equal to 2a cos kx. So the net amplitude is 2 times of the amplitude of the cos kx. That means the amplitude is not same on every point. It is dependent on x. So amplitude is dependent on x. So the amplitude of the wave is dependent on x. Here k is equal to wave number or propagation constant so its equation is k is equal to 2 pi by lambda. There are two types of amplitudes where amplitude is 0 and amplitude is maximum. Amplitude is 0 means this position is called node. So at nodes amplitude is 0. That means the graph is like this. But the amplitude is 0. These positions are said to be nodes. If amplitude is 0 means the function of cos is 0. So the function of cos is 0 for 90 degrees. That means in the order of pi by 2 we can expect the kx is 0. So function of cos is 0 for pi by 2 or the ranges of n pi by 2 also. In place of n we can substitute 1, 2, 3, 4 like this. So it is n is equal to 1, 3, 5 for odd harmonics. So therefore 2a cos kx is equal to 0. Therefore cos kx is equal to 0. Therefore cos kx is equal to n pi by 2. So 2 pi by lambda into x is equal to n pi by 2. Pi gets cancelled. Therefore x is equal to n lambda by 4. So this is the information about the nodes. That means the distance between the nodes to nodes is lambda by 4 of the order. So it is at 0 amplitude. Then what about the maximum displacement or maximum amplitude? Those positions are called as antinodes. Cos is maximum at 0 degrees, 180 degrees like that. So A is equal to 2a cos kx is equal to 1. So therefore cos kx is equal to m pi. So therefore 2 pi by lambda into x is equal to m pi. Pi gets cancelled. Therefore x is equal to lambda by 2, lambda, 3 lambda by 2, etc. So these are the values of the antinodes. For nodes, x is equal to lambda by 4, 3 lambda by 4, 5 lambda by 4, etc. These are all the odd harmonics. These are all the even harmonics. Next we will discuss a problem which is based on this concept. This is the numerical which is based on the concept of standing wave or stationary wave motions. The content of the numerical is the waves traveling in opposite directions produce a standing wave. The individual wave functions are given by y1 is equal to 4 sin 3x minus 2t centimeter, y2 is equal to 4 sin 3x plus 2t centimeter, where x and y are in centimeter. Find the maximum displacement of the motion at x is equal to 2.3 centimeter. It is the first bit. Second one, find the positions of nodes and antinodes. The general equation y is equal to y1 plus y2. So the displacement, the amplitude is equal to a. We know that y is equal to 2a sin kx cos omega t. If you compare these two equations, a is equal to 4, k is equal to 3, omega is equal to 2, compared with the general equations. Therefore, maximum displacement y is equal to 2a sin kx cos omega t. Therefore, it is 2 into what is a? 4 into sin, k is 3, x into cos, what is omega? 2t. Therefore, it is 8 sin 3x cos 2t. But here x is equal to 2.3. There we should find out the maximum displacement. So therefore, y is equal to 8 sin 3x into cos omega t. Here x is equal to maximum displacement at x is equal to 2.3 centimeters. Therefore, y is equal to 8 sine 3 into 2.3. Therefore, it is 8 sine 6.9. So, the answer is 4.6 centimeter. This is the maximum displacement at x is equal to 2.3 centimeters. Next, we should find out the position of nodes. Nodes means displacement is 0. Y is equal to 2a sin kx cos omega t is equal to 0. Cos is 0 at pi by 2 distances. So, for nodes, kx is equal to n pi. According to the given statement, k is equal to 3. Therefore, it is 3x is equal to n pi. So, x is equal to n pi by 3 centimeters. So, the positions will form at n pi by 3 centimeters. That means pi by 3, 2 pi by 3, 3 pi by 3 like that. So, for antinodes, kx is equal to n pi by 2. Therefore, x is equal to n pi by 2k. Therefore, it is n pi by 6. Because k is equal to 3, that is why we should write n pi by 6. Therefore, antinodes will form at a distance of n pi by 6 centimeters. Pi by 6, 2 pi by 6, 3 pi by 6 like that. So, this is the solution of the given numerical. So, the next concept is standing waves in a string fixed at both ends. This is the string, two ends where the string is fixed. Here, the waves which can form is maybe 1, 2, 3 within the given area. So, it is one wave is formed which is incident towards the end, and at this end it is reversed back. Or there is one more pattern. Along the same string, two waves which are alternative in the path are created and reversed back. And there is one more mode, three waves can form and from here it will reverse back. It is better to show the reflected wave in dotted lines. So, here it is a single wave, two half waves, three waves. So, what we can understand from this? These are all said to be modes of vibrations when a string is fixed at both ends. So, whenever these modes of vibrations means, consider a string which is fixed at two ends. One end is vibrated and the disturbance is started, and this disturbance was reached to the another end. There it is reflected. And here also it is same. Whenever these all the cases, you will know that the distance between two successive ends, two successive crests or troughs, or two successive antinodes and nodes is L by lambda by 2. Therefore, the distance between the two successive nodes or antinodes or compression or rarefactions is lambda by 2. So, we can say that the L-load length L is equal to n lambda by 2. Therefore, lambda is equal to 2L by N. So therefore, L is equal to N lambda by 2, where N is equal to 1, 2, 3, etc. So for first harmonic, means we are finding the frequencies of the first harmonic, second harmonic, third harmonic, nothing but the fundamentals of vibration or modes of vibration. Here the modes of vibrations are represented by N, where N is equal to 1, 2, 3, etc. So for the first harmonic or fundamental mode of vibration, N is equal to 1. Therefore, L is equal to N lambda by 2. Lambda is equal to 2L by N. So, where N is equal to 1 for fundamental mode. Therefore, lambda is equal to 2L. We know that frequency nu is equal to V by lambda. So therefore it is nu is equal to V by 2L. So therefore we know that frequency equation is also called as root of T by mu also. So therefore if we equate the both equations, therefore V is equal to V by 2L is equal to root of T by mu. Therefore V is equal to 1 by 2L into root of T by mu. Therefore frequency is equal to 1 by 2L into root of T by mu. So the frequency of a standing wave or stationary wave is inversely proportional to the length, is directly proportional to the square root of the tensional force and inversely proportional to the square root of the linear density. T is equal to tensional force, mu is equal to linear density, L is equal to length of the string or length of the column. This is the frequency of fundamental mode of vibration. Next we will see the second harmonic and third harmonic and nth harmonic. So for second mode of vibration, we know that n lambda by 2 is equal to L. Therefore lambda is equal to 2L by N. So for second mode of vibration, N is equal to 2. Therefore lambda is equal to L. So frequency nu is equal to V by lambda. Therefore nu is equal to V by L. In the first case, so this is nu 2. So when you compare this one, this is also called F2. But we can write F2 is equal to 1 by 2 into 2V by L. Therefore it is 2F1. So F2 we are getting 2F1. So therefore it is 2 into V by 2L into square root of T by mu. So we got F1 is F1, but F2 is 2F1. Means for the second mode of vibration, the frequency is increased by 2 times of the fundamental frequency. We will check the third mode of vibration now. So for third mode of vibration, We know that L is equal to n lambda by 2. From this, n is equal to 2L by lambda, and lambda is equal to 2L by n. For third vibration, we can get lambda is equal to 2L by 3. Therefore, frequency is equal to velocity by lambda. Therefore, it is velocity by 2L by 3. Therefore, it is 3V by 2L. We know that this V by 2L is equal to fundamental frequency. Therefore, it is 3F1. So, first mode frequency is F1. Second mode, the general term is F2, but it is 2F1. Third mode, frequency is F3 and it is 3F1. Such like that, nth mode, frequency is Fn, it is NF1. So when strings are closed at two ends, their frequency is increased by n is equal to the ratios of their frequency 1:2, 2:3, 3:n. So this is the possibility in the frequency of the fundamental modes or modes of vibration when the string is fixed at both ends.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.